Bismillahirrahmanirrahim. First year mathematics, chapter number 3. Topic scalar or dot product. So let's start. So what is dot product? When two vectors are multiplied and the result comes in scalar quantity, it is called scalar or dot product. Or the scalar or dot product of two non-zero vectors a and b denoted by a dot b is a dot b equal to a magnitude into b magnitude cos of theta, where theta is the angle between vector a and b. And remember that the theta must be less or equal to pi like 180 and greater or equal to 0. Look at the figure here. These are two vectors, which is the first one is vector a and the other one is vector b. It makes angle theta. The orange color has a magnitude of a and the other one is magnitude of b. So where a absolute is the magnitude length of vector a and b absolute is the magnitude length of vector b. Theta is the angle between a and b. So we multiply the length of a times the length of b, then multiply by the cosine of the angle between a and b. This is the formula for the scalar or dot product. It is important to note that if either a equal to 0 or b equal to 0, then theta is not defined. In this case, a dot b equal to 0. Remember that when one of the vector is 0, then theta is not defined, and in this case their dot product will be 0. Or we can calculate it in this way. Look at this. We can also calculate the dot product like this: a dot b equal to ax multiply bx plus ay multiply by. That is, we will multiply the x components and the y components separately, and then we will add. So this is another way of writing the dot product. Look at the diagram. Here this is the vector a and this one is vector b. The x component is ax, the y component is ay, perpendicular is the y component and horizontal is the x component. Similarly for vector b, bx, this is the x component and by is the y component. So if we multiply the x component of a with the x component of b and the y component of a with the y component of b and then add, this will be the dot product. So we multiply the x's, multiply the y's and then add. Both methods work. You can do by any of the method discussed above, and the result is a number called a scalar, so we know it is not a vector. In this way, the product of the two vectors will result is a scalar number. That's why this is called the scalar product. Important observations. Note that a dot b is a real number. Obviously, when we multiply the two vectors with the dot, it will always be a real number. If a and b are non-zero vectors, then a dot b equal to 0 if and only if a and b are perpendicular to each other. If a and b both are non-zero vectors, then their dot product will be 0. It is on the only condition that the angle between them is 90. It means that because if we put it in the formula, then cos 90 equal to 0, this means that their dot product, the dot product is 0, and this means that a vector is perpendicular to b vector. If theta is equal to 0, then a dot b equal to a magnitude b magnitude in particular. So when the angle between the two vector is 0, this means that cos 0 equal to 1. So the formula will be a dot b equal to a magnitude into b magnitude. In particular, if both the vectors have same magnitude, like both a dot a, then by putting b equal to a in the formula, we will get a absolute square, as in the case theta is 0. If theta is equal to 180, what will happen? Then a dot b equal to minus A magnitude B magnitude, because cos 180, that is cos pi equal to minus 1. So by putting the value we will get A dot B equal to minus A magnitude B magnitude. In particular, if both the vectors are same, like A equal to A, then it becomes minus A square, as in this case theta is again 180. Example, calculate the dot product of vectors A and B. Look at the diagram. Now we will calculate the dot product. So by two methods. Look at this, is the 10 is the magnitude of A and 13 is the magnitude of B, and 59.5 degree is the angle between these two. So one of the formula we will do in this way: A dot B equal to A magnitude into B magnitude cos of theta. Now by putting the values, look at this. Here A is 13 magnitude and B has A has 10 magnitude and B has 13 magnitude, and angle is 59.5 degree. Now multiply, we will get these, the answer. Look at this, A dot B equal to 65.98, rounding up it becomes 66 rounded. So this is one way of writing the dot product, or we can calculate it this way. Look at this, as we have used the formula, that is x component multiply with x component and y component with the other vector of y component, then add. Look at the minus 6. This is minus 6 because it has opposite direction, negative x6 along negative, that's why we are using minus 6. The x component of A is minus 6 and the x component of B is plus 5. Plus, look at this, the x component of y component of A is 8 and the y component of B is 12. So multiply and simplify, we will get this result, which is again equal to 66. Both methods came up with the same result after rounding. Also note that we use minus 6 for x, ax, it is heading in the negative x direction. As we have discussed that minus 6 is for the negative x direction. Expression of dot product in terms of components. And now we will discuss it along in space. Let we have a vector A equal to xi plus yj plus zk and B equal to xi plus yj plus zk. Be two vectors in space. Then using the properties of dot product we have, if we have a vector like this, then we will use the dot product like this: A dot B equal to, no, look at this, xi plus yj plus zk and xi plus yj plus zk. Now multiply these separately, we will get x multiply x, then I dot I, x multiply y, then I dot j, x multiply z, then I dot k. Similarly, look at this, if we multiply plus, look at now, turn up y a component, so y multiply x, I, j dot I, j dot I. Now y multiply y, j dot j. Now y multiply z, j dot k. Similarly, now you can multiply separately, we will get the same result. Now since we know that, as we know that I dot I, j dot j, k dot k equal to 1 and I dot j, j dot k, k dot I equal to 0, so by putting these values in the above relation, we will get x, x, y, y and z, z. That's why A dot B equal to x, x plus y, y plus z, z. Thus the dot product of two vectors is the sum of the product of their corresponding components. Note that if A equal to in a plane like x1i plus y1j and B equal to x2i plus y2j are vectors in the plane, then A dot B equal to simply is that in the above there were an z component, and in this one there is no z component in the plane. So A dot B equal to x1 x2 plus y1 y2. Properties of dot product. If A, B, C are vectors and alpha any scalar, then the properties of dot product. Dot product is commutative. Remember that we can write A dot B equal to B dot A. That's why it is commutative, because as we know that the result of the dot product is a real number, so we can take it as A dot B or B dot A. Both will have same result. Dot product is distributive over addition. Second property is, that is, dot product is distributive over addition, that is A dot into B plus C, A dot B plus A dot C. That's why it is distributive property over addition. Also we can write alpha A dot B equal to alpha A dot B, as it is a scalar number. Alpha and A and B are vectors, so we can write it as like alpha A dot B or alpha A dot B, both are same. Angle between vectors. One use of the dot product is to calculate the angle between two vectors. Like this, let A and B be the two vectors, then by definition of dot product, what will be the angle between the two vectors? It is simple. A dot B equal to A magnitude B magnitude cos of theta. We have discussed this before, where theta is less or equal to pi, greater or equal to 0. Now we will calculate cos of theta from this relation by dividing A magnitude into B magnitude. How? This becomes cos of theta A dot B divided by A magnitude into B magnitude. So this way is the angle between A and B. Now as A dot B equal to A magnitude B magnitude cos of theta, we can write cos of theta A dot B divided by A magnitude B magnitude. Separately we can write it as A by A magnitude, B by B magnitude. So this can be written as A by A magnitude equal to A unit and B by B magnitude equal to B unit. So we can write the cos theta as the dot product of their unit vectors also, like A unit dot B unit, both are same. Example of dot product is work done. One of the best example of the dot product is work done, because we know that W equal to F dot S. F is the force, S is the displacement. By removing the dot, we will put the angle cos theta. So this becomes W equal to Fs cos of theta, where theta is the angle between the force and the displacement. So look at the diagram. Here is the force applied at the upper part and it is the angle. So the dot product of these two is equal to the work done, where theta is the angle between the directions of F